Hi everybody, this is a WeeW tutorial, and today you will learn how to make a real-time clock using the DS3231. So this is the board where we do have our DS3231 or the real-time clock. So this is a kind of a small watch that we do have here. So as you can see, it's not powered on, it has only its own battery, as you can see here. And we do have the STM32F1, which is not powered on yet. But if I put this one here, and this STM is connected using the UART to the PC. So if I show you like here, and this is the UART communication. So I'm going to power my STM32F1, and you will start seeing here the time appearing, and this is something that has been programmed previously. So today in the video you will be able to do this, so to program it and to put a time, and after that you can read the time again when you want. Before jumping to the video, let me take the moment and thank everyone for their support. I will keep doing my best to provide this quality content. So as usual, to support the channel, you can give us a thumbs up, make a comment, or subscribe and stay tuned. As usual, the code that we are going to write together is available on GitHub. You can find the link in the description below. The language we are going to use is C, and the program is Scale version 5. Finally, the level here is a WeeW, which means that you may need to take a look on how we built the I2C communication library. But if you are interested more in the DS3231 and how it works, this tutorial is quite valid. So the hardware that we are going to use is, as usual, the aka Blue Pill for the STM32F1, and we are adding FTDI FT232, which is a device that we are going to use to make the UART communication between the STM32F1 and the PC. Finally, we are going to use the MH board for having the DS3231 RTC. Okay, so within this tutorial, first of all, we are taking a look on the DS3231 and have a quick review on how it works. Then we are going to set up the I2C communication function for this component. After that, we are going to create the function for setup and updating the time on the DS itself. Then we are going to write the function to get the time. And finally, we have to need to view the data, and we are going to use the UART communication for that. So if you are interested in the UART libraries, it's also available in this tutorial for the STM32F1. So let's have a quick review on this DS3231. So this is the circuit here, very simple to set up, and you can see that the communication is straightforward with the I2C communication for the microcontroller. So it's an I2C real-time clock. A real-time clock is something that keeps time internally and is quite updated by itself. You have it in your cell phones, in your PCs. It's quite everywhere. It's a quite very cheap component. It's less than $0.05, even much less than that. So it can count, of course, second, minutes, hours, date of the month, means the days, the months, the days of the week, and also the year. Also, it can count the century. It has a temperature compensated crystal, which is really great, because usually the previous model you have to buy the crystal by yourself, but this one have an internal crystal and it have a temperature compensation. So if there is a variation of the temperature, you can compensate that and reduce a lot the error that you do have in the timer. So also it has a very accurate time way, because it has the own battery that you can add there, which is wonderful. Then it has a temperature sensor, so you can get the data of the temperature of the sensor that is used to compensate the time. But this temperature sensor, you can get the data, and it's a 0.25 accuracy, which is great. It's a fast one. It's a 400 kilohertz interface, and finally it can go from 2.3 to 5.5 volt operation, which is really great. So it works for the STM32F1 and also for the Arduino. Okay, after that, let's take a look to the board that we are going to use, this MH board. So first of all, it costs around $1. It's very cheap, and it has two components. The first one, as we discussed, is DS3231, which is our real-time clock, and it has the I2C pin, which is the ground, VCC, SDA, and SC clock. And also it has the SQW, which is a square wave pin, so you can generate a square wave using that pin, or in the interrupt. So it's a double usage pin that you do have here. I don't know why they put it only SQW. And finally, you do have a 32 kilohertz output pin, which can be useful in certain cases. So on the other hand, the small device, the small chip that you see down is the ATHYC, which is a serial EPROM, and it has 32 kilohertz of memory. So we will take a look on this one in the next episode, but it's a very useful one to have together. Okay, it's for this one to just have the I2C communication, and that's all. So you just connect it and you are ready to work. Okay, so after that, so we do have in the back of this small board, you do have a battery that you can add, so you can remove it from anywhere, and it can keep counting the time. So that's a wonderful device. The operation, as said, is between 2.3 to 5.5 volt, which make it really able to use for a wide range of material. And finally, the address for the DS3231 is the binary 11011000 or the hexadecimal D0. Okay, so we had a quick review on this small device. We can go jump and create the I2C communication functions. Okay, so let's start and have a review. So this is our starting point. I prepared the file with having some libraries, so the JP drive, the help function because we need to manipulate a little bit of strings, the I2C function, the sysdig, and the UART that we are going to use later on. So we do have also this the C file and the header for the DS3231. They are two empty files for the moment. I just added the help function because we need it later on, and the I2C because we need the I2C library to build this one, and this one here ready to start. Before jumping directly to the code and start writing, I think it's very important to take a quick look on the datasheet and understand how the communication is going on. But first of all, this is the datasheet. It's a very short one. It's just 20 pages, and this is one of the datasheet that is really well written, very simple to use, very easy to understand. So I quite advise you to take a look on this datasheet. We will take a look quickly later on to see how the communication and data transfer is happening. So nothing really special on this one. We just go directly to the part where we check how it works. So if we go down a little bit here, not here, just a moment, this is the part. Yeah, and this is here where the transmission works, the read and receive. So for reading, as usual, you just put the 101, so the address here, which is as we shared before, plus the 1, and then you can read. However, there is another way to read, and this is the same way that we have made for the BNO055, is to make first as write, then we put the address that we would like to write, and after that we start reading from that address. It's a very useful way, and this is the way I would like to use to work on our way. So for reading is very simple. Writing is very simple. Reading a little bit tricky, and we can work on this one. So as usual, as we have been doing, I would like to start with some address, a void address. So let's put here, and this is so to not have to repeat ourselves again and again. So we are going to create the function that will start with the address that we do have. So this address will be, we are going just to use the I2C function for the address, the one that sent the address. So this is the I2C address, and as usual we have to specify which I2C we are going to use, and we put directly the hexadecimal D0, which is the address of the DS3231, and then we do have the read write. Quite simple and straightforward. So this will help us to quickly use this address and to change it if we use another device or we would like to have another address on this one. Then we can go and create the transmit function. Transmit function is extremely simple, as you will see together. This is something that we created many times, like with BNO55 or the OLED screen. So first of all, we have to put the I2C start. So with this function we start the I2C communication and we initiate it. Then we are going to use the function the DS32, this one, address, where we add here. So we have to add the I2C, and then we have to add only 0 because this is one that we are going to transmit and write. Okay, after that we are going to transmit the data, so the register, so we have to put I2C, register here, I2C data. Okay, that's interesting because I should have this function, so let's go again. I2C data. Okay, we have it, so we put I2C and we are going to send first the register. Okay, then we do have again the I2C data where we are going to send the data. Okay, so here instead of register we just put data, and finally we can put I2C stop. See, it's quite very simple. No need really to waste time on this one. So here I2C, and that's all. Exactly same as here for the transmission. So first we start and then we send the address as seen here. After that we have to put which register we would like. This is the address which is exactly with this line, and then what we need to do is to put here the register that we would like to read, and after that we start reading, we start writing the data on the chip that we would like to use. Okay, so after that we are going to create this function. So first of all we are starting and putting like we are going to write, and then putting the address that we would like to write, and then after that we will have the list here of how many register we would like to read. So as you can see here, this is our function. Same for BNO if you have seen it. So first of all we check which I2C we are going to use, and then which register we would like to start reading from, and then this is the array where we would like to put the data. Finally, this is the number of time we would like to read the data, and this is a chart because the register of this RTC is made of 8 bits, so we don't need to have a bigger size of data. So let's start writing immediately. So let's put int I. This is, we are going to use it for a loop, and after that, so we start immediately exactly same as this one, like this, with a small change. Instead of having 0, because we keep the 0 here, but we copy this one again. We have to restart again our here. So as you can start again, this is the start again, and we put here, we start again, but we put 1 here, and then we have the for loop. I equal to 0, I is less than data len, how many data we would like to read, and then I++, as we need to make incrementation, a very simple loop. Okay, and after that we just put str of I here will be equal to the simply I2C Rx. So we are going to receive, and we put as normal I2C and putting the acknowledge. So each time for this loop we keep acknowledging, and the last one for this one, so this is not the last one, this is before the last one, like this, because the last one, when we reach it, we can put str of I will be equal, I will just copy this one like this, but we are not going to acknowledge, we are going to have a not acknowledge, so it will stop the communication, and we end up everything by I2C. Here we stop the communication, and we do have our main function that we are going to use, and to build our other function of updating and reading the data. So as you can see, it's quite simple and immediately inspired from the graphs that we do have here. Very simple way, and I think with this example you were quite getting used to how to work with it. Okay. So we just finished setting up the I2C communication with the DS3231, and we are ready now then to create the function that will update the date and time for the DS3231. I would divide this part in two different big parts. The first one will be a little bit interesting, when the other one will be a little bit boring, a lot of quick code, but a useful one that we will use with time. And so before to jump directly to the code, I would like to take you to the register table that for the DS3231. It's a very simple table, and this is here the table, and let me make this one bigger to understand how to read. So we do have the addresses here, and the address 0 is second, 1 is minute, 2 is hour, 3 is day, but this is a weekday, so we are not going to read it this time. After that, 4 is the date, so from 01 to 31. Then 5 is the month, and this one is century, means when the number of years, which is from 00 to 99, goes over the 99, sorry, the century become positive here. And that's quite very simple and easy. So what we are going to another point very important. So if this bit is equal to 0, the number of hours will be 24, and then we have to write here. But if you'd like to put this one, this one will be AM and PM. So I don't like the AM and PM. We are going to use the 24-hour number. We are reasonable people, but if you enjoy reading AM and PM, feel free to use it in your own solution. Okay, so to write, as we have seen, so we already have the function, but to write here, it's extremely important to follow this logic. So you have to put here the decimal part of the number, and this is the tenth. So for example, if I have 35 seconds, so I have to take the part which should be in this way. So this, we need to divide 35 by 10, so we do have 3. So here we have to have 3, and here we, in the second part from bit 3 to bit 0, we have to have 5. So we need a small converter to put the data here, and after that we just can update immediately. So let's jump to the code and start working on it. So I already prepared the comparator function, so it returns a char, a very easy one. So we do have a number, which is a date or a time, depends, and so we need to create a return that, so char here, the date format, we call it like this, so it's very simple to read, equal to 0. Okay, and what we need to do is a date will be date format. Actually, it will be equal to the date divided by 10. So this is the first step to work on, and after that, so we take the date format here, and that will be equal to date format, and we need to move to the left by 4-bit position, so we are going to put them in the part of the register where it can multiply by 10. And after that, a very simple next step. So what we can take is a date format, okay, and is or equal the remaining or the modulus of the date here by 10. Sorry, like this, not 12 but 10. Doing so, we do have the right format to write in our DS3231, and we have to return at the end our date format. And that's all. You see how easy, simple, and quickly. So this is the part. It needed a little bit of thoughts, but it's just playing with bits. But if you do have a question on this one, please feel free to ask me about it. So let's jump to the next function. So you will see the next function, there's a lot of repetition, but it's something that will make our life better. So this one, we just write this this code directly here. So we need to write on this address 0. So what we need to take is we take the function that we created previously, which is the tx1 here. So as usual, we have to specify with which I2C we are going to use. And the register that we need for writing in the second is the 0 hexadecimal. And the data that we would like to write is we are going to use this function here and of second. Quite simple. And that's all. That's what we need to do. And we can jump to all the other one for this one and just change the address and the name. So you can see it's quite a very simple one. There's a little bit of repeating myself, but by creating this function we will have the ability to not confuse ourselves, and it's a very important thing. So here I'm putting minutes, and this is the address for the number one, so is for the minutes here. And after that, for the hours, same. So we just add this one here. Let me remove this one and comment it. So if we put here hours, okay, and the address is 2. So we already finished the hours. After that, what we can do is to make, this is not the weekdays, but this is the days that we would like to know, the date itself. So here you just have to be careful a little bit. So I will put date here, and I would like to know the day, the calendar day, not the weekday. So I'm jumping, so I'm not taking this number 3, I'm taking number 4 as I would like to write from 01 to 31. Okay, so I put here and 4. Let's copy this one as it's faster. And after that, so there's a little bit of repetition, so you can just download this file from GitHub and you get the data. And here it will be 5. Okay, and this one is a month. Okay, we are almost there. And finally here. Okay, so we can put it same. So we put this one, for this one we put year, which year we would like to input, and this will be 5. Okay, so now we do have the 2 remaining functions. So just to show you, year is number 6, and I forgot to add here number 6. So these 2 functions will be just the functions that we just created here. So what we can do is take, so we update for the hours, minute and second. So let's take this one. So we just put this one here, we remove the I2C and we put sec. Okay. Okay, after that we will copy everything later on. So after that we are going to copy the minutes. This one. Yeah, I don't need to put the void. So this is more so you can use this function separately, or if you want to add to use them in how to say together. Okay. And finally the hours. And here we are. So okay, so with this function we can use only one function to update the 3 of the data. After that, let's do the same thing for the to make the date. Okay, so we take the day So you can see it's quite simple, straightforward, nothing special to do. It's just to copy paste and to have a good structured data that you can use like for different data. So if later on you would like to compress the data, it's much better to use these functions. So, and after the date we are going to use the month. Yeah, and let's remove, as usual, a little bit of repetition, my apologies. You can accelerate, but I need to make it. And finally the year, where we are adding here, let me remove and uncomment this one and add also here, remove char. No, it went a bit wrong. This one, removing also the char. So the function is fully ready. And the final function that can update everything here. So let's add it here. Okay, this one will be, just a moment, okay, it's not a date, it will be a day. And after that, finally, this is the function where we can update all the data in one shot. So if we would like to change time, minutes, and everything, we can read all the data without any issue. Okay, and here I2C, brilliant. Finally, this is the last one, and by adding it we should have a full functions that they are ready to be used to update the data. Okay, and okay, so this one, day, and I2C is not recognized. Why? Because I should not put void here. Yeah, and all the data is here. So what I will do right now, I will copy everything in the header file. I will not let you see me doing it, and we can go to the next section. We made functions that update the time inside the chip, but now we need to go for getting this data from the chip. So let's do it together. So this part of the program is quite very simple and straightforward. So what we are going to do is to create a reverter. A reverter is, we need to revert the number. So as we are going to extract some data, we need to change the format that we do have here to the format that we can understand. And also we need to create a very simple function that get the time. So first of all, let's start with this one, a very simple one. So let's uncomment it. So when we get the register, the data of the register, let's create a function. So a variable, a char that we call it time. No, I call it new time maybe, or update time. So update. And this one will be equal, so when we just started, will be just equal to the time, but this time we'll have to go by 4 steps, like here to the layer to the right. After that, we are multiplying this update. We are going to multiply this update by 10, so we can have this number. So let's put 10. We got this 10. What we just have to finish now is to put update is just a plus equal to the time. But what we are going to do for the time is to remove the 4 bit that we have been looking for. So is and the hexadecimal 0f. Okay, so that's all. That's how we revert the number, and we just return the update. Okay, so just one caution for you guys. This code will work at most of them, but not for the month. Like, it will work also for the month, but just to be careful that you will have this century bit. So if you are more like sensitive to this one, you may make some condition or create 2 functions, one special for the month and one for the other one. So just for you to get more like detailed or secure when you write your functions. But as now we are quite doing this to understand how things are going, we don't really need to really focus on that one. And I'm not sure that this program will survive the century. After that, we just have this function. It's very simple. So we are going to extract the data. So we are going to extract the data for the seven registers here, and we put them in an array. So we just take the function we created before, this one, the receive function here. So we still need to specify the I2C. Okay. And for the register, we are going to start extracting from the register 0. The string is the string that we are going to get. And after that, the length that we would like to take is 7. We would like to extract 7 registers. And that's all. So it will return an array, and we will extract the data from that array directly. So we finish all the function that we needed. We have our I2C communication. We know how to update, and we can now read the data. So that's a good time to start writing the code to have the visualization. So we created the function to get the informations from the DS3231. We can now start visualizing the data. So let's put the whole program in place and have something to see. Before jumping to the main program, let's quickly copy this function that we created in the previous section and add them to the header. And the last one here. Okay, I made something wrong. Yep. Let's put this one like this and this one, and add. And I have to avoid that avoid here. I really put the wrong one here. Paste, and okay, good. So let's jump to the main program and start working our functions. So first of all, let's add the I2C. So the I2C init, and we are going to use the I2C number 2, and we would like to have the fast mode. Okay, I2C fast mode, so as it can work and it can be very fast. Then we can like immediately start updating our date and time. So we can use the function DS32 where is update, update date. So let's put here and create our functions here. So the char, let's start with the year. Now we are in year 2020. What a great year. And then char for month. We are today as October. After that, even PC doesn't accept. And we don't need a 2000 because only 21. And char for day. Today is the 3rd of October. Also, we are going to add the char for the hours is equal to, I think now it's midnight, so we can put it equal to 0. Minutes, we will update it later on, so char for minutes is equal to 25. I probably will update it for later. And char for second, I usually put 30, so just in case, as I'm not seeing it in my computer. Okay, so for this one here we use the I2C, and then for the year we just put year, and after that we put the month. Okay, day, hour. Okay, so this is update date. Actually, it's not date, the one that I want. I would like to update the date and time. Okay, date and time. So year, and after year is hours, after hour minute, and then second. Okay, so we do have our function ready. So as soon as we run our program, this function will be working. Okay, after that, so everything is good, so we can start and jumping to our loop for reading the data. So what we need here is, first of all, let's start reading the data using this function, the ds get time. So each time we are going to get the time, so the I2C we are going to use is 2, and we will need a function that will read this one, a variable. So it will be a variable char that we call it, let's say, timetable, just to be time table like this, and it has 7 positions. Okay, so we put here timetable. Okay, brilliant. So we do have the timetable, and what we would like to do is to have a kind of array where we put all the data there. So what we can do is just we add an array here. So within this array we will have kind of the time and the date. So let's put char and create both arrays. So we could time and we put 12 position, and also the time and also date. Yeah, I think, yeah, that's fine. Date, and we put also 12 empty position. Okay, not 22 but 12. Okay, so what I'm going to take each time, so I'm going to take in some data and put it within a string, and after that I will be displaying the string. So let's go back here to the driver. So something is wrong here. This one I need to put it, yeah, that's a mistake. Yeah, that's great. So let's create one small function, another one, and this one will create the integer to time, because we are going to read the data as an integer, and we would like to add it to a string to create a certain to create a certain string that we can display using UART or whatever other one. So let's call it void int date, for example, int to date, and that will have 3 inputs. First of all, char of the time that we are going to add, and after that we have the string that we are going to build. So char here we call bstr, very simple. And also I will add another one, is separator. So the separator will be something, if it will be date, it will be a special separator, and if it will be time, it will be a special separator. So you will see later on. So we called separator. Okay, so what we are going to do here is, first of all, let's make a number, because we are going to convert the integer that we are going to read to a string. So let's have a small array, we call it num, and that have only 3 memory space. After that, so if the length of the string that we are going to input, so lnstr, so this function is got from the help func, which we added here, and this is the help func, is a library, small library we created together to manipulate and get some very useful function about strings. So if the length of the string of the str is strictly greater than 0, then, so if it's strictly greater than 0, then we start by adding the separator first, because it means there's already some data inside. So concatenate string, and we are putting str, and after that we have to put the separator. Actually, now let's do something different, not using the separator. We are going directly using the string here, so it will be easier to understand, like this. Okay, so we are going to add this one because this is for time. So let's call this one time, not date, and we will create a date, so it will be easier to understand. After that, we are going to convert into char function, so into char here, and we are going to add first the time, and we are putting the time number inside the num array. So this is to convert it. So if here, where this is very interesting, len, let's str of num here is equal to 0, just in case. Okay, so if that's equal to 0, means there is only one digit on this one. So first of all, we are going to, just a moment, concatenate. So where is the issue here? Into char, of course, I forgot the T here. And so what we are going to add here, so we are going first to add to str a 0. Okay, and this is to have a consistent number. And if it's not, we directly concatenate here for the string and we add num. Very easy, quite simple. And we end up this one by putting str empty. We better to empty this the num1 just in case. And here you are. So this is the first one. And if I change a little bit here and put, instead of time, I put date, and just the only difference is to add this anti-slash. So you can see you can put it in the same function, but I wanted to make it a little bit different, so for you guys you can understand the difference and not really getting confused. Okay, and add this one, and instead of time I will add date separator. Okay, and we are definitively done with the drive, and we can jump back here. So we read all the data inside the timetable, so we do have all the data here, and we can then start immediately doing and reading our data. So we can start building the first, how say, sentence. So first of all, we can do int to time, or this one, and we start building one by one. So int time, and we can read. So ds, we do have our DS3231, and we are going to use the reverter here. So that's what we are going to use. So the reverter of this table, timetable here, and we are putting 2 for the 0 for this one. Actually no, actually we are going to start using the hours, so we are going to put 2, and then we are going to use the time here. Okay, so we are going to implement. So what's happening here? Y time f. Okay, too many argument for this one. Of course, because I should close this one and it should be correct. Okay, and after that, so we put the hour, then we put the minutes, right, 1, and we put inside the time again, we put the second. That's all. Like, you can see how fast and easy it is. So after that, we will send time using UART, and this is coming soon. After that, we are going to do exactly the same thing. So after sending, we need to clean and delete all the data from the time. So we will put here at the end so we don't forget it. So str empty for both time and also str empty for date, else it will create a little bit of conflict. Okay, let's copy here again. So we are going to put date here. Okay, and for this one, date, I had to put it. Okay, and for this one too, we put date. And so normally we have to start with year 6, and then 5, and then 4. So now we could read the whole data. Okay, I think that's perfect and clear. So what we can do is to start updating and putting the UART communication so it become proper. So to start the UART communication, let's put it here. So we are going to use the UART function. It's a very simple function. So include UART drive.h. Yeah. Okay. And let's say we are going to connect. So if you forget or you don't know which pin to use, you can see here. And for me, I'm going to connect using UART2. So if I go quickly and show you, so I'm going to connect the UART2 with the FTDI, sorry. So this is the connection that I will have, and the program that I'm using as usual is hterm. Okay, so before doing that, let's go back here and start. So we are going to use UART2, and to set up it is UART init is a very simple one. UART init, and we are going to use UART2, and we would like to have a baud rate of 115,200. Okay, so we do have this one. Let's have a greeting. So UART, this is the function to send a message. So we use UART send, and we can say hello WeeW. Okay, and we can add back to space. Okay, so just in case, and we put a small delay, a delay of just 500 millisecond. Okay, just to understand ourselves. Okay, great. So this is done. What we can jump. Okay, something is not right here. Yeah, because I have to specify which UART I need to be using. Okay, so this is updating the time, and here we are getting the data. So now what we need to do is just send. So here is UART send, like directly. I can copy this one and paste it here and paste it here too. So instead of this one, we just put time, and we put here date. I'll be adding after that just one long line, so we can recognize easily the next line like this. And I'll be adding an extra line, so we can, whatever you want, so you can do like this. So this one here, and also another one here, and another one before. Just, I think that's fine, having all this like. Okay, so we should be good. So we do have, we are getting our data using this. This is the function that gets the data, and then we are going to use this converter to put the time inside it. And finally, so we are showing the time and the date. So let's save, build. Okay, wow, that's quite impressive. So 0 error, 0 warning. Let's start. Let's go and take a look at the where is it? hterm. So I think I didn't connect it yet. Go back. Okay, that's connected. So let's run and see what's happening. We do have hello WeeW. Oh, it's too fast. So let's make a delay function here of 1 second, so we can see like every second what's happening. So let's put 1000 and build. Maybe to clear is better, and we should see something. Nope. Okay, so let's run again. Okay, not even a hello WeeW. What's going on? Let me just reset it just in case, and that's not working at all. What's going on? Okay, let's take a look. It was working until we pushed the delay. Save, build, no error. Okay, what I'll be doing then, well, I will show you here. I'll be removing this guy here and put it back again. Okay, and after that I will send it again and nothing is happening, so something is going wrong. Disconnect, connect. Okay, so the data is not flowing. Let's check, let's remove this one because this was the change. If I put here and I run, I think at least I should have, I think this is a problem with the UART itself. So if I go to the debugging mode, yeah, this is always happening, and this is a part of the fun of doing these kind of things. Okay, so you see I'm lost somewhere, something is not going right, and this is okay, the I2C is getting wrong, something is not working for the I2C. Okay, so the I2C got totally lost, probably here. So let's check what is happening. So it was working properly. Okay, refresh. Not really. Okay. Okay, I just removed the battery and I am putting it back just in case. And here I should, yeah, let me put it back. Okay, so we do have some data, and I think I know what did happen. Okay, so now it was a battery issue, so I just changed the battery and it's working. But you can see it's a bit too slow. Let's put this one, it's timer, and refresh it. So now I do have every second. Okay, so we can see that we do have the right time, but there's a problem. I don't have, yeah, of course, because I should put date here. Date and date. So we are far from 25 now, it's already 44. Wow. Yeah, let's save, build. Okay, and let's take a look how things are going on. Hello wheel. Okay, so what we do have here is, now this is the time 44, and this is like the year, so it's 2020 October, and it's a 3rd of October. That's working properly, so you can see that we can read the data. So let's go a little bit further than that, and let me, so what I'm going to do right now, so first of all I'm going to remove this where is it, this function, because this function is the one that updates each time, so I have to remove it, build and load in my program, so it keeps reading the time. So what I'm going to do right now is removing the power from my STM32F1, and you can see, so we closed the STM32F1 and we do have 45 minutes and 19 seconds. So so if I go back again, you can see that some time has been passed. I didn't spend that much time, but a little bit of time has already passed. So you can see this is working, and the battery is taking the remote when I power off the STM32F1. Okay, so I hope you enjoyed this tutorial. I think that's very simple to do, but something very useful in real life. Thank you so much, and see you for the next episode.